vision statement was fairly simple. Focus on expanding access to digital fabrication so anyone can make anything. In 2011, that was when Formlab started from the MIT Media Lab. MIT has access to a lot of printers worth 300,000 and above. It requires a technician who is trained to use it. We wanted to make a 3D printer that was as powerful, easier to use. We are targeting to bring down from 300,000 to approximately 3,000. In 2012, we received funding in Kickstarter back then, where we actually drew almost 3 million. And since then, we have actually launched not only Form 1, but we have upgraded it to Form 1 Plus in 2014. And then the big change was in 2015, when we introduced Form 2. While Form 1 and Form 1 Plus were targeted towards hobbies, Form 2 was ready to be used by professionals. This year, we launched next iteration, which is a Form 3. Same size as the Form 2, but we have also launched Form 3L, which is able to print up to 5 times bigger size prints. We currently have over 20 types of materials. And finally, we launched a new resin this year, photopolymer resin award. It can print any objects here up to 5 times faster. 50,000 printers in a 3D printing market. We have already printed over 40 million parts. Last year, we launched a partnership with New Balance. They wanted to explore the use of 3D printing in their high-performance shoes. Typically, a high-performance running shoe would be built on what we call EVA foam. And EVA foam, after 20,000 steps, tend to be compressed, so it changes the shape. So the two problem statements that New Balance wanted to address was, can we create a material that is even lighter than EVA foam? The second challenge they wanted to address was, can we create a material that can outlast the use of EVA foam? What we did was we developed a special resin called rebound resin. So with the rebound resin, this was actually for comfort. It will last you a long time. The end result is we now have a shoe, a performance shoe that can actually outlast the EVA foam, as well as lighter. Gillette as a world leader in shaving technology. So they wanted to connect with their customers even better by offering the ability to customize your own individual shaving. Earlier this year, we launched with Gillette this program. It's called the Razor Maker. User can go online, they can choose 4 different customization: color, the shape, material. They can have their name personalized into every razor. We work with Samsung Medicine on the ultrasonic scanner. Typically for a designer, they will design it using CAD, and after which they will probably have it sent for prototyping, which means they outsource it out, and it may take days or weeks for the parts to come back before they can actually touch it. With 3D printing, the product designer can actually design, print it within hours, and hold it in their hands. The savings is both in terms of time as well as cost. This means that they can shrink down the product development lifecycle significantly. Korea in that list was just slightly behind Germany as a number 5. Asia Pacific contributes 40%, which is actually more than 1/3 of the total world manufacturing. The other reason why Korea is a very important market for us is because Korea has excellent product design capability. And with the tools that we provide them, which are cost-effective and high quality, we hope that we are able to help the Korean product designers leverage on technology to get products out to market much faster.
We have developed our own in-house technology called the low-force stereolithography, where we have encapsulated the whole optics and the critical components into one box we call the LPU. We made sure that the laser is always perpendicular to the build plane, and this makes prints consistent throughout the entire build plane and incredible accuracy. And the flexible tank is another critical component in this low-force stereolithography. The idea behind it is that forces during the 3D printing is minimalized by deflecting out of the way when 3D printing. So by minimalizing this force, what we've managed to achieve is the incredible detail that can be preserved in 3D printing. Another thing I'd like to highlight is how smooth it is. It's the 25 micrometer XY resolution and the build volume of 14.5 times 14.5 times 18.5 centimeters. Some information in regards to the maximum part dimension of printed parts and the quantity of it. In the shaded region here is what we can see is covered by the Form 3. You can see that the vast majority of it can be 3D printed in Form 3. What we paid attention is this added line. This is the cumulative volume of the parts. So to break into this new market, what we did was introduce the Form 3L to cover a vast majority of the market. It's around 5 times larger in terms of build volume when compared to the Form 3. And the whole idea of LPU is that so you can add another LPU and have a bigger printer. So you may be worried a bigger printer may mean slower, but that's not necessarily the case. Considering the Form 3 and the Form 3L both runs in the same laser, you can see the same detail but with bigger parts.
실질적으로 완제품 자체로 아직까지 승부하는 시장의 트렌드는 형성이 아직까지 안 돼 있는 것 같아요. 포커싱하고자 하는 것은 매뉴팩처링, 디지털 제조 혁신, 우리나라의 본사를 둔 글로벌 기업들하고 디지털 제조의 혁신 자체를 글로벌 레퍼런스화 시키는 것들이 저는 하나의 목표이기도 하고요. 폼 3L, 특히 한국 시장에서 폼 3L을 기다리시는 분이 되게 많아요. 내년도에는 3배수 성장이 지금보다 가능할 거라고 생각을 하고 있고요.